Hi everyone, today's lesson is going to be about half-life. So the LO of today is going to be that students will be able to utilize the concept of half-life to determine the absolute age of a sample or a rock. Alright, let's get started. So as a starter, I want you to put your prediction hats on. So the question is going to be predict whether dinosaurs' age can be determined using carbon-14. Think about that question as we go along the lesson. Alright, we're just going to do a quick recap. Remember that carbon-14 was made from cosmic ray. When cosmic rays hit the nitrogen-14, it becomes carbon-14, which is unstable, which is the radioactive isotope of carbon. And this is what we're going to be using to determine their absolute age. So radioactive decay is the process by which an unstable element changes into another element that is stable. So as we discussed previously, that carbon-14, the unstable element or the unstable isotope of carbon, changes into another element which is nitrogen-14 and which is stable as well. So we call carbon-14 the unstable isotope, we call it the parent isotope because it was the original one. When it turns into nitrogen-14, we call it the daughter isotope. Which leads us to another concept, which is rate of decay. In simple word, it just means that the time it takes for an isotope to break down or to decay. So I have the red line, which represents the parent isotope, which is the carbon-14, which is unstable. And it shows that as we go along first half-life, second half-life, third half-lives, and so on, the amount of the parent isotope decreases as we move along. So in the y-axis, we have the percentage of the parent and daughter isotopes. Alright, I said half-life a couple of times now. Kept on saying half-life, second half-life, third half-life. But what does it actually mean? So half-life is the time required for half of the parent isotope to decay and become a daughter isotope. Again, what does that really mean? So I have the parent isotope, which is carbon-14, and then it's going to decay into nitrogen-14. So when the percentage becomes 50-50, so now I have 50% of my carbon-14 and 50% of my nitrogen-14. This time it takes for it to become 50. This is the half-life. When the sample or organism is still alive, the percentage of carbon-14, which is the parent isotope, is going to be 100%. And when we as scientists test the sample and we find that there is only 50% of carbon-14, which is the parent isotope, and 50% of nitrogen-14, which is the daughter isotope, this indicates that one half-life of carbon-14 has passed. Similarly, when we find that there is only 25% of carbon-14 in the sample, now we can say that two half-lives of carbon-14 have passed. So I have 25% of my parent isotope and 75% of the daughter isotope. So what is the half-life for carbon-14 now? Which is time it takes for the carbon-14 to decay into half of its original amount. So the half-life for carbon-14 is 5,730 years. This graph shows the decay rate of carbon-14, but from a different perspective. We have here the percentage of carbon-14 remaining versus the time in years. So if I have a sample with 50% of carbon-14 remaining, it means that the absolute age of this sample is 5,730 5,730 years, which is the one half-life of carbon-14. Same as if I have only 25%, the age of this sample will be 11,460 years. So let's try and solve some practice problems. So find the absolute age of this fossil where it was found to have 50% of its remaining carbon-14. So as I said, if it's 50, it means only one half-life. So in here, you can pause the video and try and have a go on your own. So the answer will be that the age of this sample is 5,730 years. Practice 2. Also find the absolute age for this fossil if it has two half-lives. So you just multiply 2 by the one half-life of the carbon-14, which is 2 multiplied by 5,730 years. Just use the calculator and the answer will be 11,460 years old. Okay, practice 3. Now find the absolute age for this fossil if 3 half-lives of carbon-14 have passed. So I have 3 half-lives, so I'm gonna multiply the one half-life by 3. So it's going to be 3 multiplied by 5,730 years. The answer will be 17,190 years old. Now we all know that radiocarbon dating is a great method for determining the age of a sample. But however, despite its usefulness, radiocarbon dating has a number of limitations. We're just gonna only discuss one today. So the only issue with radiocarbon dating is that it can only determine the age of samples that will be less than 50,000 years old. The question then arises, can we use carbon-14 to date dinosaurs? It's given by scientists that the age of dinosaurs is around 250 million years old. So have a think now. If carbon-14 can only date samples for up to 50,000 years old, can we use carbon-14 to date a 250 million years old dinosaur? Have a think. Well, apparently the answer is going to be no. Why? Because carbon-14 is used to date only samples up to 50,000 years old. Now it's plenary time. Find the absolute age for this fossil if 6 half-lives of carbon-14 have passed. Please have a go on your own and write your answers in the comments below. I hope this video was helpful and thanks for watching. Bye.